discussing the further topic the motion at time. Here the uniform motion and the non-uniform motion is the three terms. Now today discussing about the topic of uniform motion, non-uniform motion. What is meant by uniform motion and what is meant by non-uniform motion? Listen children, uniform motion or periodic motion or uniform speed. So here uniform motion or periodic motion or uniform speed. Listen children, here the uniform motion, here the motion is uniform, here the motion is periodic motion, here the speed is uniform. Listen children, what is meant by uniform motion or periodic motion or uniform speed? Listen, the particles which are moves with equal distance and equal interval of time is called uniform motion or uniform speed or periodic motion. Listen to me children, uniform motion or periodic motion or uniform speed, it is nothing but it is defined as the particles, any particle which are moves from one place to another place, any particle which is moves with one particle to one position to another position with the uniform motion with the equal interval of time. The particles which moves with equal distance and equal interval of time is called uniform motion. Uniform motion or uniform speed. Uniform speed or periodic motion. Listen to me children. For example, in uniform motion, pendulum of a clock. The pendulum of a clock, you have to observe that in a pendulum. In support, the pendulum is suspended by means of thread. If you have pulled the side and after release them, the motion is occurred. That motion is a uniform motion or periodic motion. Listen to me children, the pendulum of a clock, if you have to observe that, it pulled aside and moves to and fro motion occur. The to motion and fro motion is occur. The motion is uniform motion. Listen to me children, another example is the periodic motion. The time, clock, we have to observe that. Minutes hands, hours hands and second hands. In every clock, how many hands are there? 3 hands are there. One is hours hands, minutes hands, seconds hands. Listen to me. Any clock, they contain 3 hands. One is hours hands, minutes hands, seconds hands. Listen to me. This is the minutes, hours hands. This is the minutes hands. This is the seconds hands. These are moves with the periodically in uniform, the equal interval of time, and equal distance traveled. Equal interval of time, equal distance, and equal distance traveled, equal interval of time is traveled. That is, the motion is periodic motion. That motion is the periodic motion. For suppose, if I observe that the motion of the earth. The earth revolves around the sun. Earth revolves around the sun. Earth revolves around the sun, which is a periodic motion, which is the uniform motion, which is the uniform speed also. Here, earth revolves around the sun. Listen to the picture. This is one of the circular object and Earth revolves around the sun. The earth revolves around the sun. This is one of the periodic motion example. Now, next one, non-uniform motion or non-periodic motion or non-uniform speed. Listen to me, children. What is meant to be non, which is different? What is meant to be uniform? Uniform means it is same. Listen to me, children. Non-uniform motion. Here, motion is not a uniform. It is a quite different in motion. That is a non-uniform motion. So, what is the definition of the non-uniform motion? Listen to me, children. The particle moves with unequal distance. Unequal distance. The particle which are moves with unequal distance and equal interval of time. Unequal distance and equal interval of time is called non-uniform motion, non-uniform speed or non-periodic motion. Here the motion is not the same. That means it is a periodically different. That means they travels with unequal distance and equal interval of time. That is called non-periodic motion. Here the examples of non-uniform motion is the motion of the butterfly. The motion of the butterfly. The butterfly moves during around the surface of the earth's space, during the atmosphere. What we have to observe that the motion of the butterfly is different in motion. It is not in a periodic motion. So it is the best example for the non-periodic motion. Another one is housefly's motion of the motion. Houseflies, mosquitoes. Those are the examples of the non-periodic motion. Another one, the motion of the kite. The motion of the kite in atmosphere is different in motion. Now children, listen to me. Here the motions are different types of motions are there. Here some motions are having uniform motions are there. Some motions are non-uniform motions are there. What are the uniform motions? Uniform motion, another name is periodic motions. The periodic motion is nothing but uniform motion. What is meant by uniform motion or periodic motion? The particles are moves with the equal distance. The particles are moves with the equal distance and equal interval of time. Equal distance and equal interval of time is called uniform motion or uniform speed periodic motion. Now, what is the examples of this uniform motion? It is the motion of the pendulum of a clock. The motion of the pendulum of a clock. It is the observed that in the suspended of pendulum, you will pull aside and release them. What will be happening? The motion of the pendulum is bobbing, moves to and fro motion will be accelerated there. This is the best example for the uniform motion or periodic motion. And it is the clock. The minutes hands, hours hands, minutes hands, second hands. The motion of the hands are moves in periodically occur. The motion of the swing of girl. The motion of the swinging of girl. What will be happening? The moves to and fro motion of the girl. The person is moves to and fro motion. It will be occur. And for suppose a person is riding on the bicycle along the surface of the road. They moves uniformly. What will be happening? They cannot skip. For suppose the person moves randomly and non-periodically, what will be happening? The person, the riding the bicycle, a person, they fell down fastly. So because the condition, they cannot control the speed. They cannot control their motion. It is a non-uniform conditions. In uniform condition, they cannot fall down. So observe that non-uniform motion, non-periodic motion. The particles are moved with unequal distance and equal interval of time is called uniform motion. Example, it is the motion of the butterfly. The motion of the butterflies are moves up and down directions. That means different directions. Because houseflies, mosquitoes, those identifies different motion. The motion of the kite in space, in atmosphere, is different motion. So here, these are the speed and the uniform speed and non-uniform speed. These are having scalar quantities. These are having scalar quantities. Listen, children. What is meant by speed? What is meant by speed? Here, the speed is nothing but children, speed is defined as speed. Speed is nothing but it is the rate of change of distance. The rate of change of distance. The rate of change of distance is called speed. Now, speed is equal to distance by time. Distance by time. Now, speed is a scalar quantity. Speed is scalar quantity. Now, speed is a scalar quantity. What is the SI unit of speed? What is the SI unit of speed? It is the meter per second or meter second inverse. So, the speed is nothing but the rate of change of distance is called speed. The speed is equal to the distance by time. The speed is a scalar quantity. What is the SI unit of speed? Meter per second or meter second inverse. What is the CGS unit? Centimeter per second or centimeter second inverse. Now, children, listen again. What is meant by speed? The speed is nothing but the rate of change of distance is called speed. Speed is equal to distance by time. The speed is a scalar quantity. What is the SI unit of speed? Meter per second. Here, meter second was also. CGS unit of speed is centimeter per second or centimeter second inverse. Now, today discussing another topic, another sentence. It is the conversions of speed from one system of unit to another system of unit. Listen to me, children. Now, kilometer per hour. 1 kilometer per hour is equal to 1 kilometer per hour is equal to how many meter per second equal? Here 5 by 18. 1 kilometer per hour is equal to 5 by 18 meter per second equal. Here suppose 1 meter per second is equal to 18 by 5 kilometer per hour equal. Listen to me, children. 1 kilometer is equal to how many meters? 1000 meter. Now 1 hour is equal to how many minutes, sir? 60 minutes. Now how many seconds, sir? 3600 seconds equal. So simply 1 kilometer per hour is equal to 1 kilometer is what? 1000 meter divided by 1 hour means what? 3600 seconds. Listen to me. 2 zeros, 2 zeros, 2 fives, 2 ones, 2 18s. Simply 5 by 18 meter per second. So 1 kilometer per hour is equal to 5 by 18 meter per second equal. So thank you children. It is completed of this topic. Okay, thank you.